Alright, welcome. This is 4.5 isosceles in equilateral triangles. So make sure that you have that header at the top, 4.5. Alright, first thing that we are going to write down is we have some vocab right here. Alright, so all I really care about is we have this vocab. Just draw this picture right here. This is all that really matters. Okay, so we're talking about an isosceles triangle. Okay, so maybe you've heard about it before, but isosceles triangle, it has congruent sides of the isosceles triangle are called the legs. So we see that both these sides right here are the legs and they are congruent to each other. That's why we have the lines right there. We said that the other side, that third side, is called my base. So that's the base right there. And then the two congruent legs form the vertex. So where they come together right there, that angle right there is called my vertex angle. And then the other two angles are the base angles. So the other two, these two right here, are my base angles. Okay. So all you really need to do is have that picture drawn right there. You don't need to write the definitions. Okay. All right, and then let's get to a couple of our theorems that we have. So my first one, and make sure you have this written down with the picture, and it's 4.3, so everything inside this box. Okay, all it says is if two sides of a triangle are congruent, then the angles opposite those sides are congruent. And so remember, what are we talking about here? We're talking about an isosceles triangle, so a specific type of triangle. But we're saying that if two sides of the triangle are congruent, then the angle is opposite. So we see that this is an isosceles triangle, and if these two sides are the same, well then it must mean that these two angles are the same. So that's one theorem I have. So make sure you have that all written down. And then my next one that I have is going to be very similar, but it's going to be my converse. So I have this right here. And all we're doing is we are taking the converse of the one that we just had before. So remember, converse is we have my hypothesis, my conclusion. All we're doing with my converse is we are switching them. So we said before that if the sides are congruent, then my angles are going to be the same. This one, we're saying that if you have congruent angles, then the two sides are going to be congruent. So if the two angles of a triangle are congruent, so it's just rearranging it this time, if those are congruent, then the opposite sides are going to be congruent. And again, these applies for my isosceles triangles. Okay. All right. Let's keep going on. Our next theorem. All right. 4.5 says, the theorem says, write down everything inside this box right here. It says if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. Okay, so what that means is that we have an isosceles triangle, and to bisect it, remember bisect right there, really important, means that it like splits it into half. Okay, so if it splits this into half, you can see on my figure that we are saying that that angle and that angle right there, those angles are the same. Well, with an isosceles triangle, when this comes down here, you'll see the picture that we have right here. I'll draw it here so we can see it. These become perpendicular, which means that they are 90 degrees. And it also splits these sides into half as well, because it bisected that as well. Okay. So make sure you have that drawn down. I would mark this picture over here so you know what is happening. Alright, and let's go. We have two more theorems. Our next one, oops, skipped over it. Our next one is, we have, these two right here. Okay, so we're kind of going away, we're kind of going away from our isosceles triangles, and we're just talking about a different type of triangle. So the type of triangle we are talking about, and you're going to write down everything inside that box, we're talking about an equilateral triangle. Okay, so we have all this right here. So theorem 4.3 and theorem 4.4, we're talking about an equilateral triangle. Now an equilateral triangle, what is that? Well, it means that all the sides are going to be equal. All the sides are equal to each other. So they're all the same side. And so what we're saying though is that when With an equilateral triangle, that also means that all the angles are going to be the same as well. So if they are all the same, that means that each angle is going to be 60 degrees. Because 60 times 3 is 180. Remember, a triangle interior angles add up to 180 degrees. Okay, and then my theorem for 4 is just saying the opposite. Okay, if a triangle is equilateral, then each three of these angles are 60 degrees. If that is the case, then each of my sides are going to be the same length, which is going to make an equilateral triangle. Okay. All right, let's go into a few examples. All right, so problem number 1 says, is AB congruent to CB? So again, we're talking about segments. So it wants to know, is this right here going to be congruent to CB? That right there. So we look at this right now and we see, what do we have? Well, we see these two sides are the same, but what we really need to notice is we got to see that down here that it tells me that these two angles right here are the same. And so remember, we said when the two angles are the same, then my two legs are going to be the same too. So what would we write down? So yes, we know that these two sides now, because those two angles are the same, we know that these two are going to be equal to each other. Okay, so we would write down, let's uncover it. Yes, so since angle C is congruent to angle A, then my two sides, angle AB and CB, are congruent to each other. And how do we know that? Remember, that was my converse. We just switched it up of my isosceles triangles theorem. Remember, that just said if my angles are the same, then my two legs are going to be equal to each other. Okay. All right, let's go on to our next one. All right, so my problem number 2 right here is we're going to try and find x right now. So make sure that you have the picture drawn out, and let's find the value of x. Okay, so we see that we have these two sides are congruent. So remember, my theorem says, like, if the two sides are congruent, then my two angles are going to be congruent. Okay, so if that right there is 54 degrees, then this one over here has to be 54 degrees. Okay, so I got one of the angles. And really, these triangles are split up into two. So all I want to do is just break it off into one and solve the one triangle. So I see right here that I have these lines and this show congruence. So remember, we talked the theorem that we had that said that if it bisects the vertex, and this up here is my vertex, where the two bases come together, that's my vertex right there. And we said if we have a bisector that bisects the vertex, so these angles are equal, well, then it said for my isosceles triangle that at the base it's going to form perpendicular angles. So that's going to be 90 degrees. Alright, so now all I'm going to do though is I really have this one triangle and I have two of the three angles. So let's redraw that triangle right here. The triangle looks something like this, where we have 90 degrees right there, we have 54 degrees right there, and we're trying to figure out how many degrees is x. Okay, so remember, interior angles of a triangle, they add up to 180, so we take x plus 54 plus 90 is going to equal 180. So I add these two together, I get x plus 144 equals 180. Next thing, I'm just going to subtract 144 from both sides. And this is going to leave me x, and I get 180 minus 144 is 36. So I get x equals 36 degrees. That'll be my final answer. So remember, I got to know all these theorems in order to figure out how the angles are the same, and that when it bisects an isosceles triangle, that it forms perpendicular angles at my base. So it's important that we remember all those theorems. Okay. All right. So my last problem right here, it says, what are the measures of angle A, angle B, and angle ADC with this picture right here? Okay. So I want to find these three angles. So I'm trying to find angle A, that angle right there. I'm trying to find this angle right up here, And let's do a little highlighter. I'm trying to find this angle right there. Okay. So, thing that I notice is, alright, so what I notice though about all three of these though is that I see that they have all the same sides. Remember, if they have all the same sides, then they are equilateral triangles. And I see all three of these are equilateral triangles. So, if I clear this off, I know that my angle A right there, this angle right here, my equilateral triangle has equal angular angles, which means that each angle is going to be the same, which means that each angle is going to be 60 degrees. So I have, and let's clear this right here, let's write it one more time. I have angle A right here is going to be, angle A is going to be 60 degrees. I have, so that's 60 degrees. I have this one right here is also going to be 60 degrees, so angle B is going to be 60 degrees. And then my last one, I'm looking at this one, so it says ADC, so ADC. So if I look at this one, I know that this angle right here, because it's equal angular, is going to be, that's going to be 60 degrees. And this angle right here is also an equilateral triangle, which means that this angle is going to be 60 degrees. And what I'm trying to find that angle right there. So it's like two of them combined together. So I take 60, add it with 60 is like double. So it means that angle ADC is going to be 120 degrees. Alright, perfect. As long as you remember, equilateral triangle has equal angular angles, which means that each angle is going to be 60 degrees, and we are golden. Alright, see you guys.